Hello everyone, I'm Mario Garcia. I'm so happy to be here sharing with the global Python community at Conf42 Python 2023. Today's talk will be about how to generate test data for your database project. I'm a technical evangelist at Percona. You can find me on Twitter, LinkedIn, or you can contact me by email. And this is the agenda that I will follow today. If you need to generate data for testing your application or validating the schema of your database, you have two options. You can get a dataset from sites like Kaggle and then use pandas for processing that data and insert that data into the database. Or you can use a data generator. We have one that is available in one of our repositories, but it only works for MySQL. If you need a data generator for Postgres or MongoDB, I will show you how you can use Python for creating your own data generator. First, we need to install the dependencies for our project, create the database where we will insert the data that we will generate. I will explain the directory structure. I will show you how you can use Faker, that is a library for generating data, and also how to create a pandas data frame. We need a data frame for storing the data that we will generate, and then how to establish a connection to the database, how to define the schema of the database. We have two options here. We would use SQL Alchemy for establishing the connection to our MySQL or Postgres database. And SQL Alchemy has a schema definition language that we can use for defining the schema. But as we are using pandas, uh, pandas has a built-in method for inserting data into SQL databases like MySQL or Postgres, and we would use that built-in method for that. And also we will see how to use multiprocessing for improving the runtime of our application, and then we will see how we generate data by running the scripts that we will create. First, we need to create a requirements.txt that will contain a list of the dependencies of our project. Or if you're using Anaconda, we need to create an environment.yaml file that will contain the name of our environment, the version of Python that we are using, the libraries that we are using for this project, including Pandas, SQL Alchemy, TKDM, that is a library for adding a progress bar, Faker, that is the library that we use for generating data. And also we need the drivers for the database that we are generating data for, including MySQL, Postgres, and MongoDB. After we add that information into our requirements.txt file or our environment.yaml file, we need to install our dependencies by running pip install, or conda create, depending on the way that we are configuring our development environment. Then, after we install our dependencies, we need to create the database. This is an example. You can adjust this information according to the requirements of your project. But first, we create a database for MySQL or Postgres. For MongoDB, we don't need to do that. The database and the collection where the information will be stored is created while running the script. And well, this is the directory structure of our project. We have three modules. One for establishing information about how to establish the connection to the database, including information for MySQL, Postgres, and MongoDB. And here, this module will contain instructions for generating the data and storing that data into a pandas data frame that will later be processed for inserting that information into our database. And here in the schema.py file, we specify um, the schema of our database. We will see that later, but we are not using SQL Alchemy schema definition language here. We create an environment .py file, a requirements.txt file for our dependencies. As the way for establishing the connection to the database and inserting the data into our database is slightly similar for MySQL and Mongo. We create a script for both database technologies, and we create a separate script for MongoDB. Well, how we use Faker? Faker has some built-in providers and properties that we use for generating data. Name is one of those properties. So first we need to initialize, well, we need to import Faker and initialize Faker. And then by calling one of the properties, we generate 10 randomly generated names. This list will change every time you run this code, as this data is generated by using a random method. What providers and properties are available with Faker? We have some built-in providers, but also we have some providers created by the community. The ones listed here are the built-in ones, the ones created by the developers behind Faker. And well, these are some of the providers that are available, including person that we can use for generating name. This will generate a pair of first name and last name, or we can generate those data separated by calling the first name and last name methods or properties. And we have an address providers that we can use for generating address, city, or country. We have a job provider that can be used for generating job, company, an internet provider that we use for generating email or company email. Well, now that we know how to use Faker for generating data, it's time to create our script. First, we need to import some libraries and methods that we would use for the whole process. First, we import this method from the multiprocessing module. CPU count will return the number of CPU cores available. We need this information as we are implementing multiprocessing for using all the CPU cores available. We will see that later. And then we import pandas as well as TQDM and Faker. TQDM is a library for adding a progress bar. We create and initialize a Faker generator. We get the number of CPU cores available -1. This way we avoid that the computer freezes when using all the CPU cores available. So instead, for example, instead of using 16 cores on a CPU that has this number of cores available, we use 15 of them and we leave one free to avoid that the computer freezes. Okay, and these are the columns that we will add to this table, and we will generate that data by calling some of the properties available in the Faker library. So we will generate first name, last name, job, company, and the other columns listed there. So how we generate that data and then insert or store that data into Pandas data frame. So first, as we are implementing multiprocessing, the idea with multiprocessing is that we divide the whole process into small pieces. So instead of, for example, if we are generating 60,000 records, we divide that number of records into every CPU core available, and every CPU core will generate part of that information, and then we will concatenate that data for uh, creating a single one pandas data frame. So that's why we are dividing the number of records that we will generate into the number of CPU cores minus one. Then we create a data frame, an empty data frame, and we will create all the columns in the data frame and assign as values the values returned by calling some of the properties provided by Faker. Okay, now that we have generated data, it's time to establish a connection to the database. This is part of the base.py model that we created before that I explained as part of the directory structure. So what we do here is first we import the create engine and session maker methods. The first one for establishing the connection to the database, and then we create a session that is bind to the connection that we're establishing to our database. So for MySQL, we use this driver. So we need to specify the database technologies that we are using, plus the driver that we will use for establishing the connection to the database, as well as running all the queries that we need. Okay, then we specify user, password, um, the URL for the host, that can be localhost or the IP address or a URL if you are hosting this our database in the cloud. And then we create a session and that is bind to our connection to the database. For Postgres, the way to establish a connection is similar. Um, what changes here is that we are we are using Postgres and we are using a different driver. We need to specify user, password, the port that that is assigned to this server, and the name of the database. Then we create a session, and for MongoDB we use PyMongo. We establish a connection to the database by calling the Mongo client method. We need to specify the user, password, the port, and the URL of our MongoDB server. Okay, so there are two ways for defining the schema of our database. We can use the schema definition language provided by SQL Alchemy, but remember that we can use SQL Alchemy for MySQL, Postgres, and SQLite, but we can use SQL Alchemy for MongoDB. So this time we are using a built-in method provided by Pandas for inserting that data frame that we previously created into the database. And the way that we define our schema is different from the way that we define the schema by when we use the schema definition language. So we only need to specify the name of the columns, the value of the value types, and then, well, um, after we define the schema of the database, we need to understand why we are using multiprocessing. With multiprocessing, we take advantage of all the CPU core available. So after when we are running this script, this is how the CPU uses um, appears, for example, in our uh, monitoring tool, Bergona Monitoring and Management. This is how we see all the CPU running in part of the process at the same time. So that's why we are implementing multiprocessing. Instead of having just one CPU core running all the script and generating all the records that we need. For example, we are generating 60,000 records. So by default, Python will only use one CPU core. So with multiprocessing, we divide all the process into small pieces, and every CPU core run part of the script. And for example, here we are using 15 CPU cores, and every CPU core is generating 4,000 records. After that, we concatenate all that data into a single one data frame. Okay, after learning a little about multiprocessing, we need to import all the methods and libraries for the rest of our script. We are going to create a multiprocessing pool for running every for every CPU core to run part of the process of generating all the data. We need to get the CPU get the number of CPU cores available by calling the CPU count method. We need to import pandas as well as some of the methods available as part of the modules that we created before, including the base.py, schema.py, and dataframe.py, by calling some methods available there. And then we call well every CPU core call the create data frame method, and every CPU core will generate 4,000 records, and then we concatenate that data into a data frame. And for MySQL and Postgres, we are calling the to SQL method provided by pandas. We need to specify the name of the table where that information will be stored, the the database connection information, and if that data exists, we will append that data. We can change that later. And also we need to specify the schema, the one that we defined before, so that pandas know where to insert all the information. Okay, for MongoDB, this is the way that we insert data into MongoDB database. First, we need to convert uh, the data that we generated into a Python dictionary. Um, then we need to specify the name of the database and the collection where the information will be stored. And by calling the insert menu, we insert all the data. to the MongoDB database. After we inserted, after we insert the data into every database, MySQL, Postgres, and Mongo, we need to modify the tables, especially for MySQL and Postgres, because we are not defining a column in that table that will be our primary key. So we need to add another column, and we need to, this will be auto increment values. And the way that we do that for MySQL and Postgres is slightly different. So for MySQL, we will execute this SQL statement, alter table employees at ID, that will be our primary key. This column will be not null, and this will be an auto increment. The values will be auto increment. And with the first option here, we are saying that that column will be added at the beginning of the table. For Postgres, we don't have the auto increment option. We have what we have in Postgres is the serial option that is similar to the auto increment in MySQL. So this is why we have two different instructions for both database technologies. Okay, so it's time for running a script. We can, well, I already created a repository where you can find all the scripts that I explained here. And I'm using an Anaconda, but you can install all the dependencies by running pip install. But if you want to use Anaconda for better managing your environment and all the dependencies of your project, you can download it here. You can find installation files for Windows, Mac, and Linux. Then we install Anaconda. This is the instruction for Linux distributions. And then we clone the repository. You can find the repository that contains all the example that I explained here. And at this repository, we change to the data generator directory, configure the Python environment by installing all the dependencies and configuring the environment. This will create the environment defined in the environment.yaml file. We need to edit the base.py module that contain information about how to establish the connection to the database. And then we run the script. And finally, we can check the database for the data that we generated by running this script. Here are some resources that can be useful. You can check the Faker website. You can find more information on bundle providers that are the ones that are available with Faker by default. You can use community provider. You can find more information on the website. You can check the SQL Alchemy website, as well as check the schema definition language to know how you can define the schema of your database by using SQL Alchemy. We didn't do that because we are using the built-in method provided by Pandas for inserting data into the database. Here you can find more information about using multiprocessing to make Python code faster. That is the idea behind multiprocessing. Instead of having one CPU core running all the tasks in our script, We have all the CPU cores available running part of the process, and we can improve the runtime of our application. Okay. Okay. So here you can find more information about the careers available. Uh, I just want to say thank you for being here, and I really enjoy sharing with the community today. If you have any questions about what I shared today, you can contact me on social media or by email, or you can also check the blog post that I already published about this topic. And I'm planning to update the code of this project